For years, the narrative has been that an AI takeover is inevitable. But the systems powering this technology didn't just appear out of nowhere. They were built on a massive, unauthorized extraction of human creativity. The firms building these models treated the open web as a free warehouse. They deployed automated scrapers to vacuum up billions of images, voice notes, and paragraphs. The original creators were never asked for permission, and they were never paid. Much of that haul went into a single open dataset called Lion 5B. This diagram shows the scale: 6 billion scraped images and accompanying text. This hub became the foundational learning material for Stable Diffusion and most of the art tools that followed. This repurposed human effort became the raw material for generators that can now reproduce those same styles in seconds. Creators paying attention started recognizing their own work in the output. Artistic styles and techniques that took decades of practice to develop were being mimicked by machines in a heartbeat. A career's worth of experience was reduced to a text prompt, undercut by a tool that cost nothing to use. The developers did offer an opt-out system, but it placed the burden entirely on the creator. Instead of asking for permission up front, artists had to hunt down massive models, file individual requests one by one, and hope the companies actually honored them. The companies behind the models freely admitted to their practices. OpenAI even told the British Parliament that building today's top models without using copyrighted work would be completely impossible. The legal and technological balance of power heavily favored the developers. Polite opt-out forms and copyright notices weren't stopping the scraping. The creators needed a way to fight back. Since creators couldn't stop the automated scrapers from taking their files, they adapted. They decided to control exactly what the scrapers were eating. This split-screen visualization shows the mechanics of adversarial machine learning. While a human looks at the left and sees an illustration of a dog, an AI model looks at the right. It only sees a dense structural grid of numbers and vector data. Programs like Glaze and Nightshade exploit that gap in perception. They subtly manipulate those underlying numbers. To the human eye, the image remains completely unchanged, but the machine learns from the disguised information, mistaking an oil painting for charcoal or a handbag for a toaster. This exact same trap is being applied to audio. A tool called Safe Speech slightly smudges your voice's unique audio fingerprint. To another person, the recording sounds perfectly normal, but the crucial details an AI needs to clone your voice get scrambled into static. Academic researchers, notably the team at the University of Chicago, developed these tools as free software that functions without breaching firewalls or hacking servers. By exploiting the gap between human and machine perception, creators found a way to turn their own portfolios into Trojan horses, perfectly hidden in plain sight. The trap is executed passively. Artists post their work online like they always have. When the automated web scrapers arrive, they vacuum up these customized, poisoned files, completely unaware that the data is corrupted. Nothing looks wrong at the time. The trap only springs months or years later, during the model's multi-million-dollar training run, when the AI attempts to learn patterns from those deceptive numbers. The results of a poisoned model are bizarre. If someone prompts the AI for a photorealistic dog, the generated image comes back riddled with errors. Extra joints appear where they shouldn't exist, the fur loses its structure, and the face subtly melts into something deeply uncanny, or drifts entirely into concepts like cats and cows. This cluster diagram illustrates the extreme vulnerability of these systems. A model might train on billions of images, but it relies on a much smaller subset for any single concept. It takes less than 1% of carefully targeted corrupted data to spread a disruptive wave that destroys that concept inside the AI. The insurgents don't need to poison the entire internet. Just a few precise drops of corrupted data are enough to break a multi-billion-dollar system from the inside out. AI labs couldn't afford to lose access to the data fueling their models. They tried to fight back by retroactively filtering datasets, checking scraped images against captions, and scrubbing files through cleaning models before training. Those defensive tactics are failing. Tests show that filters miss up to 60% of poison files. Worse, the cleaning process routinely flags and deletes massive amounts of clean, necessary data by accident, leaving the models with either contaminated data or not enough material to learn from. It's an asymmetric arms race. You have decentralized researchers constantly releasing new poison patches in a matter of weeks, easily outmaneuvering the slow, highly expensive fixes developed by giant AI labs. The AI companies are losing a war of attrition. Their automated, frictionless data pipelines have turned into slow, highly vulnerable liabilities. The true target of this insurgency is the foundational economic premise of the AI industry. Investors poured tens of billions of dollars into these systems on a single bet, that the data they scraped would remain free, endless, and clean forever. Because a poisoned file looks completely identical to a real one, the concept of clean data is dead. Every unverified scrape is now a potential sleeper cell. To avoid corruption, datasets now require prohibitively expensive manual checking, which sets projects back by weeks and drives up costs. The only reliable way to guarantee clean data is to buy it. Companies like Adobe and Shutterstock are already striking legal deals to actually pay creators for licensed, uncorrupted material. By altering their files at the source, creators have introduced a significant financial risk to scraping. If unvetted data becomes too expensive to clean, the business model of relying on free, unconsented web scrapes becomes much harder to justify.